Well, welcome everyone to week 3. This is Dr. Waite checking in with our lecture material for this week. We are digging into chapters 6 and 7 of the textbook. So make sure that you're reading along in those chapters this week and that you take some time to go through the PowerPoint slides that I provided. Again, the slides are generated from the textbook, so you'll see the same content, just focusing on the main topics within the slides. So this lecture, I'm going to start off with chapter 6. We're going to get into the elbow and the radial ulnar joints. So I'm just going to kind of go through and briefly highlight the main parts that you should pay attention to. So starting off, when we're looking at the elbow, we're really dealing with not just one joint. Oftentimes you hear the elbow and you think or elbow joint, you think of there's just one joint there. There is one primary joint that's referred to as the elbow joint, and that's the hinge. And the hinge is actually the interaction between the humerus, or the connection between the humerus, the distal end of the humerus, and the ulna, all right, which is your inside forearm or medial forearm bone. That's the main hinge joint itself. There's actually 3 joints total in the elbow. So you have the hinge, and then you also have the radial ulnar joint between the 2 bones in the forearm, and those joints actually occur at a proximal and a distal end. So you have a connection here between the 2 joints near the wrist, and then also at the elbow, and that's allowing for a pivoting, gliding motion. And then you also have the interaction between the head of the radius and the humerus, the humeral ulnar. The humeral radial. So just to kind of highlight each one of these, just recognizing that you have 3 bones interacting there, and all 3 bones connect and each have their own joint. So technically there's 3 joints. Together, there is a synergy effect, right? The function of the hinge, the pivot, and the gliding motion of each of the 3 joints allows you to move and rotate simultaneously. Allows you to basically flexion extension is the main action at the elbow, but really there's also a rotational effect occurring at the forearm, both proximal and distal, near the wrist as well. And so when does this really come into play? Well, think about like an overhead throw. If all your elbow could do was hinge, you wouldn't be able to get the rotation to get like a curveball or really just throw a ball effectively. So very, very unique joints located at the elbow region. All right, so some key things to pay attention to. Just look at the interaction between 3 bones. There's some key bony landmarks like the olecranon process, which is actually the end of your elbow. And that's actually if you didn't know that, if you didn't know this or didn't realize it, the elbow bone, or the end of the elbow, known as the olecranon process, technically is actually part of the ulna. It's not actually the humerus, so it's part of the forearm bone. It's kind of interesting. So a lot going on there. Just make sure you're paying attention in the slides. If you look at slide 3, it starts talking about the bones and the different landmarks, like medial condyloid ridge, the olecranon process, as I mentioned, the carotenoid process, and the radial tuberosity are all key landmarks where muscles are attaching through tendons and allowing you to pull and manipulate the elbow, such as with the biceps brachii, the brachioradialis, triceps brachii, and so forth. Okay. All right, so I'm going to skip through the bone section and move on to the joint section itself, which starts on slide 7. So the first joint we're looking at is the ginglymus, or the hinge type joint. This is the main interaction between the humeral ulnar joint and the humeral radial, radiohumeral. It's one of those backwards ones. Joint. By the way, a little side note on that, you'll notice that there with the name of the radiohumeral joint, joints are typically named by the most proximal bone first, then the distal bone in connection. So in this case, it's one of those that's kind of backwards. So like the traditional way of looking at it would be humeral ulnar, because it's humerus connecting to the ulna. Hint, the humerus is closer to the midline of the body, so it's labeled first. But the radial humeral is one of those backwards ones. There's a couple other ones like the subtalar joint down in the ankle. It's a little bit backwards, but anyways, fun fact there. All right, so what's going on in the elbow itself? So the radial head connecting to up with the capitulum, which is basically the round ball object on the lateral condyloid into the lateral condyloid of the humerus, and the radial head is just rotating around that capitulum, allowing for the pivoting, gliding action to occur. There's some information on stability, range of motion, how many degrees of motion should you get at the elbow, the role of the different ligaments that are in the elbow, and it's basically giving its stability and its structure. Talks about some common injuries, the Tommy John procedure, basically repairing that UCL ligament. Let's see, what else should I point out here to you? Let's move on to the radial ulnar joint. This is the actual pivot joint where the radius is pivoting over the ulna. All right, it's that pronation, supination motion. Okay, let's check out the structure of that. There's a slide showing you a good image of what the radius and ulna look like together on slide 16. I'm going to skip down. There's some information on synergy, movement between the glenohumeral and the elbow joint itself, the hinge, and then the radial ulnar, and how muscles interacting at the same time, crossing both joints, are allowing for the dynamic motion that you see in the upper arm, both at the shoulder and the elbow simultaneously, giving us that synergy effect. All right, moving on to the motion or the movements on slide 21. The main motion at the elbow, of course, is flexion and extension, or main two motions. So flexion, you are closing the angle, so you're using the biceps brachii to flex the elbow, and extension is returning to that extended state, or which it would be your anatomical position, right? So to leave anatomical position, you have to flex the elbow. To return, you have to extend, okay? So flexion is controlled or created by the biceps brachii, whereas extension is created by the triceps brachii. But I'm getting a little ahead of myself. We haven't added the muscles yet. That's later in the PowerPoint. So the next movement is pronation. Of course, if you're starting anatomical, pronating would be flipping the palm over, right? So you're pronating, the radius is pronating over the ulnas. The way I like to think of it is also like the radius radiate or rotating, radiating, however you want to say it, over the ulna. A good way to try and remember it there. Supination is just opening the palm back up, back into anatomical position. Next, we start adding the muscles on slide 25. You can see the elbow flexors, the biceps brachii, the brachialis, the brachioradialis, and the pronator teres. And then the extensors are the triceps brachii and the anconeus. Then there's some images to show you that. Looking at the pronators and supinators, some of the bigger muscles in the wrist, I say bigger with some sarcasm because they're not that large, but there are many muscles, both superficial and deep, within the wrist that are controlling, helping to manipulate the forearm. And then it gets a little bit further, looking at the anterior and posterior supinators and pronators, so you can take a look at those. It highlights some of the nerves that are innervating through the forearm. So we have the radial nerve, the median nerve, and then the musculocutaneous nerve. Okay. And the rest of the slides are just highlighting the functions of the main movers at the elbow. So starting off with the biceps brachii, the brachialis, then the brachioradialis, and then we look on the backside at the triceps brachii and the anconeus. Then it goes in and gives you some details on slide 41 and going forward on all of the pronators and then the supinators. Okay. There's some examples of exercises on when these would occur, the use of each muscle, so you can go through and check that out. And then it ends with some good website um, links for discovering more material on the use of these muscles and so forth. All right, I'm going to move on to chapter 7. I know that was brief. I'm going to kind of keep this one short. A lot of this is going to be up to you, looking through the slides and just seeing the images, studying the muscles, and looking at their function. It's pretty straightforward. It's really about memorization of the muscles and their line of pull and how they manipulate the arm. Okay, so next we're on to the wrists and the hands. Key thing to take into consideration here is now we're dealing with more fine motor skills. So there's a lot of bones, a lot of muscles, a lot of joints involved in the wrist and the hand. This is a very important structure to look at because obviously we use our hands for a lot of things, and certain sports that require more precise functioning, such as the manipulation of objects like they're listed here. You have archery, bowling, golf, baseball, tennis. And you can just think about the action of just even gripping a baseball and throwing it to get a curveball and so forth. A lot going on there. Within the hands and wrists themselves, there's about 29 bones, over 25 joints involved, all functioning simultaneously as you move and manipulate the hand, and then of course 30 muscles that are working to help manipulate those joints and move the hand. All right, so bones. We have 8 carpal bones. We have which make up the wrist itself, and then we have 5 metacarpal bones. Right in the hand, you can see the 5. So you have 1, 2, 3, 4, 5. All right. Your number 1 would be your thumb. So your thumb is your first digit or your first, metacarpal bone, all the way to the 5th on the little finger. Then you have 14 phalanges and digits for each. Each one has three phalanges within each digit. So you have your proximal, or you have 3 digits within each of the phalanges. Let's put it that way. You have your proximal phalanx, your middle, and then your distal. Obviously, the thumb only has a proximal and distal. There's no middle. All right. You can take a look at all of the carpal bones, from the scaphoid to the lunate and the triquetrum, the pisiform, the trapezium, trapezoid, capitate, and hamate. All right. It goes into detail of each one. I'm going to kind of skip over this. You can look at the pictures and so forth. I'm going to move down to the function of the wrist. The wrist joints themselves are condyloid type joints, which allows for basically 4 primary movements: flexion, extension, and then abduction and adduction. And together, they can basically create a circumduction movement because of their function in both planes simultaneously, which is what allows us to have that fine motor control of the hands and the fingers. Gives you some information on degrees of motion, so you can take a look at that on slide 14 and 15. I'm going to move forward all the way to the movements themselves. So the wrist will flex and extend. It will abduct and adduct, and then the fingers will flex and extend. And then some of the joints will, the metacarpal phalange joints will abduct and adduct, but the phalange joints themselves, they only flex and extend, right? Which allows you to bend your finger up and down. They're not really meant to go, that way. That would hurt. Let's see what else we have. Movements. It shows you examples of wrist flexion and then wrist extension on slides 25 and 26. 24 and 25. And then on 26, it shows abduction. Another name for abduction is radial flexion because you're flexing towards the radius. And then adduction adduction would be ulnar flexion because you're flexing towards the ulna. Can't talk today. Let's see, more movements showing you the fingers, how they function. All right, moving down to the muscles on slide 32. We have multiple muscles in the wrist that are helping to manipulate, in the forearm that are helping to manipulate the wrist. So the three wrist flexors are the flexor carpi radialis and flexor carpi ulnaris, and then the palmaris longus. And then on the opposite side, you have the extensors of each of those, along with so you have a radius longus and brevis, and then the ulnaris. And then it shows you some images of these flexors and extensors and how if you cut away the extensor digitorum, you can see all the extensors underneath it. And same with the flexors. Talks a little bit about carpal tunnel syndrome, just like overuse of these muscles that leads to swelling and inflammation that can affect nerves. And I'm going to kind of skip all the way through. It talks about manipulation of the hand, the different muscles in the hand, a lot going on there. You don't need to memorize every single muscle in the hand. There's a lot of them. Just understand the functions and the categories of each and the motion itself. That's the primary focus. And then you get all the way down to slide 46, and it starts to get into the location of the wrist and hand muscles, just more images to give you more of a clear picture of that. Talks about the nerves. We have a radial nerve that comes through and innervates into the wrist, which then leads to the median nerve, and then which breaks off into an ulnar nerve throughout the radius into the hand. All right, and then that gets down into the muscles themselves. So on slide 58, moving forward, it's just reviewing all the muscles one by one and each of the functions that occur with each muscle. And then the key here is as you're working through these muscles and looking at the slides, understand the grouping of these muscles that, yes, individually that they have specific functions, but it's more collectively what they're doing. Because they're such small muscles, the key is that they're really working together to manipulate the wrist and the fingers. So that basically ends the PowerPoint. The next 30 slides are all just showing each muscle and their specific function. And then it gets into each motion and all the muscles that work together. So like I said in last week's presentation, there's two ways to approach studying this. You can look at the actions and then all the muscles that are related to that action, which is what I like to do because I think of it more as a functional perspective. Like, how do we function? What muscles are involved in that function and that motion, and what plane of motion are we dealing with, and how do we use this in sports and exercises? And then there's another perspective to look at, okay, let's look at each muscle individually and what does it do. But ultimately, you want to combine the two concepts together. Know the muscles and their actions, and know how they pair together to basically assist each other and produce effective movement. Okay. Well, that sums up chapters 6 and 7. Please spend some time going through these slides and refreshing your anatomy, and ultimately not just the structural anatomy, but the functional anatomy. Just know the functions, know the movement, know how to apply it, and you'll be successful with this. All right. As always, if you have questions, feel free to reach out to me. See you next week.